Hello, classmates. Let me get this started. Right here. Awesome. Let's get started. Uh, so, my name's Mariah Skinner. I am a runner for Utah Tech. I run cross country and track. And so this study really fascinated me because I am an endurance runner. But yeah, this is the research paper I did. Pre-exercise carbohydrate meal and endurance running capacity when carbohydrates are ingested during exercise. I can't say Costas's last name, so I'm gonna just refer to the researchers as Costas and Clyde. We like them, they are from England. Awesome. Let's get started. So to begin with, we know that carbohydrates has always been super important in sports. We know that we've heard of carb loading. We love our pasta. We love our, spaghetti, all of that. It's always been something that athletes have had and um, something that has been proven to help them. We also know that carbohydrates can come in many forms. I like the little donut right next to this bullet point because as sometimes we think that's unhealthy, it is a form of carbs. And we see that in the study that they'll use two different types of carbohydrate intake. And then the last point is for athletes, we know that it's important for us to know what to eat and when to eat, and we are always looking for those type of answers. At least I know I am. And so the purpose of the study, Costas and Clyde, they wanted to figure out or to prove that having carbohydrates during exercise can benefit athletes instead of just before or after. Because we like we said, we've learned about carbohydrate, like carb loading, so good, but like what are the benefits of having them in? And so that's what they did. So the way that they conducted this study is they had 10 male volunteers. They all volunteered, and all of them were similar in age, height, body weight, VO2 max, and their maximum heart rate was all like the same. I think like the range was like from 2 or 4 plus or minus on each of these. So they were like really close. Um, Something that's important is that they all knew what they were getting into. They all agreed to it. And before they did this test, because the test was 3 certain types of tests, we'll get into that later. But before they did that, a week before that, they tested their relationship between running speed and oxygen intake. And they tracked their maximum oxygen intake by uphill treadmill running, which sounds miserable to me, but they did it. And then they also got them used to the treadmill by just having them run 60 minutes, get used to the environment. They wanted it to be fair and level for all of them. The procedure of what they did was that each participant, once a week for 3 weeks, would run to fatigue on a treadmill at 70% VO2 max. And to ensure that they were running to their max to fatigue, even when they felt really tired, they would maybe slow down the treadmill for 2 minutes to 60% VO2 max, and then they would have them go back up to 70%. And so they were literally running as far as they could, which also sounds exhausting. But the first round was 3 hours before the test, they had them have like a high carb meal. And for some reason, I was thinking pasta and all of that, but actually, it was just white bread, jam, cornflakes, all that good stuff. And it was really high in carbs, low in fat, low in protein, all that jazz. So they had that 3 hours before, and then during, they were given this carbohydrate electrolyte solution during their trial run. The second time, they had a liquid placebo 3 hours before, and then they had that same carbohydrate electrolyte solution. And then the third time, they didn't have any carbs really. It was just a placebo before, a placebo during. And during those like 3 hours while they waited, they made sure that it was low intensity activities. So some of them brought work, some of them read a book. Like it was chill 3 hours after they had it. And then some of the things that they recorded during it was their air samples, capillary samples. So those were collected the first 10 minutes, then the next 20 minutes, and then 20 minutes after until they stopped. And then they would get it 1 minute before they stopped. So that's how they would track what we're going to see in our results. So the results, the biggest thing that was found was that both the first and second trials, which had the carbs during the exercise, did increase their exercise time. So that's a big thing, is that they were able to go longer when they had the carbohydrate during. But to go along with like these graphs, we see in this bottom one, I hope you guys can see my mouse. So the first trial was called M plus E. I think of it as meal plus carbohydrate is the top one. And we see that this is the respiratory exchange ratio, which also indicates a higher carbohydrate oxygen rate, which is found up here. So those two work hand in hand. And because these are so beneficial, that's why they were able to exercise longer and have that energy longer. And so we see that up here and up here, they had that more energy. And then it came down, of course. And then we see the placebo one didn't get really high. In fact, it just went lower or stayed the same. So that's important to look at. Along with that, the blood glucose concentration at exhaustion was higher in the first trial compared to the second and third trial. And what that means is that blood glucose is pretty much your blood levels, your sugar blood, all that good stuff. And that's like the energy for the cells and the tissues. And so that's really important in terms of carbohydrates because that's where the glucose comes from and helps with that energy. And so we see what was interesting is that it's at the end. At the end, they had more of this energy saved, which is really cool to see because we see this again, M plus C, that's the first trial with the carbs before and during. They had more at the end right here. And we can see that even with the second trial that had the carbs during it as well. Other things that I thought were interesting. The rate of perceived exertion was lower in the trials with carbohydrates than those that didn't, which sounds appealing to me because I don't like being tired. And then also the decrease in body weight was higher in the first trial compared to the others. And I wonder if that's because they ate more before, but that's also an interesting find, I think. And then something that was brought up that I feel like kind of don't help the proof all the way, but something that I think is cool and I'm glad that they showed in their results was that between the three trials, the oxygen intake and the heart rate were not affected. Like all of those like maintained the same between all three trials. And same with the blood lactate concentrations. And I think this is fascinating to me because if I want to increase my oxygen intake, more of my VO2 max, oh well, I guess that makes sense. But if I wanted to increase that, I wouldn't be eating more carbs. Should probably go run in the mountains or something. So that's good stuff. So to tie it all together, Costas and Klein did find that their hypothesis was right, that having carbohydrates during exercise would benefit the athletes. And why these are so important, respiratory exchange ratio helps assess the needs of the body. Does it need more carbs? Does it need more fats? Carbs is more high intensity. Let's produce more carbs. And so that's why they were connected in the other slides. And also, if it was low intensity, then they would produce more fat. The body would produce more. So since the body was telling them we need more carbs, the carbohydrate oxidation rate, well, it's triggered, and it helps perform. Well, it'd give the body more energy. It would help them with more muscle contractions and also to sustain that energy, which as a long distance runner, I want to run my best at the beginning and run my best at the end. I want to sustain that energy. And so that's really, really beneficial. And then the blood glucose concentration, we talked about this. This helps gives energy to the cells and the tissues of the body to help with all of these things, which is we need energy, and all of these things helped with energy, sustaining the intensity, and healthy recovery. So good stuff. In conclusion, this study shows the benefits of consuming carbohydrates during exercise and that it helped the participants. I think the study was pretty well laid out and pretty fair. Something that they mentioned was that there were 10 athletes or 10 participants, but only 9 of them, well, there was one of them that didn't complete the third trial, and I am curious about that person and why he didn't finish it. I definitely believe the results of this study. I think that it is proven and carbohydrates can help. Like I have had an experience during a marathon where we eat that magical banana and wow, it feels so good. So I believe there is lots of results. I believe in these results, but I would also be curious to see if the participants were not so alike, because I feel like every body is like, I don't know. I feel like everybody is different, and so I'd be curious to see like if they did females or if they did, I don't know, different ages, would it have the same effects? I feel like that'd be interesting as well. Um, and then to end with, I think this is super good to know. We started with athletes want to know when to eat, what to eat, how can they perform at their peak. And I believe that this study has shown a little secret of what we can do to help these athletes. So if you're like playing football or soccer, like make sure you're getting those carbohydrates like during a timeout or when you're on the bench. Hopefully that never happens, but make sure you're having those carbs because they will give you that burst of energy and helps with recovery too. So that is what I found. I hope you guys learned something and that you have a great day in wherever you're at. Bye.